first I need to define probability very quickly. Let's say, hypothetically, I can draw, and these are some stuff that we were. Okay. Now, let's say I have choices of colors to pick from. Okay. So let's say I have 4 colors. And don't ask me about the name of these colors, I don't know. Good. So, now, if I tell you what is the probability of you choosing a color, let's say blue, out of this, it would be 1/5. Why is that? Because in total you have 5 choices, so whatever your total is, you're going to put in the denominator, this guy, and the number of things you're going to pick, it would go on top. So I told you just pick one color, which is, I don't remember what I told you, but I guess blue, right? Now let's say I decided to have this too, pants, and again you have some choices of colors there. So if I ask you what is the probability that you're going to pick red, you're going to tell me 1/5 because you have 1 red color out of 5 colors, right? Now what if I tell you what is the probability that you're going to pick blue as t-shirt, so this is blue, and red as the pants, right? So you want both of them at the same time. So anytime for our level of probability, right, which is non-disjoint, independent, but there's too much, I'm not going to define those. Anytime we have and, right, and you're going to multiply two things, right? That's going to save you a lot. So what was the probability of picking blue? It was 1/5. What is the probability of red for pants? It was 1/5, right? Now my question is, did you care about the color of your shirt when you were choosing the pants? No, right? So that's why we can say these are independent. I don't care about the color of this when I'm choosing this, right? Or vice versa. These are just random picking. Maybe you are fashion designer or something, you care, but I'm just talking about random things, right? So random, right? Now, if I ask you, you have 2 colors for shoes, this, you can tell I'm not a designer, and this, right? So shoes. So what would the probability be? It would be 1, because you can only pick one color, hopefully. For shoes, let's say I want to pick black, so it's 1 over, in total I have 2 colors for shoes, right? 1, 2, so it would be 1/2, right? So now I'm asking what is the probability of having blue shirt and red pants and black shoes, right? So I said and, so I said and, so I have to multiply all of these. So it's 1/50, right? 2 times 5 is 10, times 5 is 50. So the probability that I pick this and that, so anytime I say and, you're going to multiply, right? Keep that in mind. Each stage, I just focus on what I had on that stage, right? I didn't care about the past or future. It's just independent, right? And anytime I say and, I multiply, right? Okay, let's just solve a few questions. I found a few in here. Yeah, so just gonna go quickly solve these based on what we said. Okay, so this person has autosomal recessive, right? So the chance, so he's small a. What is the chance he got these genes from his parents? 100%, right? So you're not going to calculate that probability. So anything is 100%, it's just 1. You don't need to write it down because you're multiplying. Now, what is the chance that dad has a negative allele and the mom has a negative allele? Wouldn't that be 100%? Why am I saying that? Because one of these genes must come from dad, right? So he must have had it, and one of these must have came from mom, so she must have had it, right? So it's AA, right? You may think of uniparental or stuff like that. Just don't go too far. It's just easy peasy, right? We're gonna do very simple cases, right? Now, so we know dad is definitely a carrier. So I put a dot, that means he's a carrier, right? So this is not a probability. This is 100%. He is a carrier. Same as mom, who is deceased. Now, so mom has a negative gene, right? So it must have came from the previous generation. Let's not talk about mutation and stuff like that. Simple, easy peasy. So we have two parents, right, for this person, right? So parent 1, parent 2. One of them must have had it, right? So what is the chance that mom had it? Is 1/2. What is the chance dad had it? 1/2. Why am I saying that? It's the same as what we had here, right? You want to pick a color, right? You have two choices. You 1, 2. So you want to pick one of them, so it's 1/2, right? You only have two choices. She has two choices. Like she has two choices to have the negative gene. It's either this choice or that choice, right? So each one has a probability of 1/2, right? You may say, well, what if they both had it? Yes, it's possible, but we're talking about autosomal recessive, and they are very rare in population, so we're not going to do that. We're just going to keep it simple, right? But what we say is we are sure one of the parents had it, right? So now assume this person had it. So I'm going to associate a probability of 1/2 to grandma of this person, right? So I assume grandma has this disease. I'm going to the next step. So what is the probability that this person who marries this person now, they have a baby, what is the probability that the baby gonna have the disease? So I assume the dad doesn't have it. Why not? Because it's autosomal recessive. It's very rare, unless they tell us some numbers. There's some of the question, I assume they have some numbers, but anyways, not this one. So just assume this person doesn't have it. So he's big A, he's fine. But the grandma is big A, small a. Well, you may say, didn't you say it's a possibility? Yes, I said it is. Now I'm going to next step. So these are independent events. So if I'm calculating the probability of this, I don't care the probability of this one, right? So this is just history. Now I'm thinking about this, right? And my assumption is this person has a mom who is a carrier, right? So just forget her probability, assume she definitely has it. Like she has it, right? So what is the probability of she gives it to her? She has to give one of these two genes, right? It's too messy, I guess. So she has to give one of these two genes, right? Big A or small a. So what is the chance you're going to pick a small a? Is 1/2. These are two possibilities. You're going to pick 1/2. So it's 1/2. Why didn't care about this? Well, he only has one choice of giving good. He has only A, so it's 1/1. So I don't care, right? So, or you can just draw the square and find it out. But I think it's just one. It just makes sense. It's 1/2. So far the probability of grandma has it is 1/2. The kid has it is 1/2. So now the next stage, I don't care about the probability of this or even this, right? I'm just gonna talk about the baby. Now I assume this person is a carrier, right? This is a carrier, right? So wouldn't that be, let me just draw them here. So this is the mom, this is the dad. You want to have a baby. Well, the question is asking about the baby who is affected by the condition, with this condition. right? So the mom and the dad should give small, right? What is the chance the mom gonna give this small or negative gene? Well, it's 1/2. See, 1/2, because I have two choices in total. It's either small a or big A, right? Same as here. It's 1/2, right? Now, let's look at all the probabilities we had. So we have 1/2, 1/2, 1/2, 1/2. I'm just gonna do this. So it's 1/2, 1/2, 1/2, 1/2. So I have 4 1/2s. So it's 1/2 times 1/2 times 1/2 times 1/2, which is 1/16. You may say, well, why didn't you just write down 1/4 for this part? Yes, you could. I just wanted to show you. So the whole point is, at each stage, right, you don't think about the previous one or the next one. If you make assumption that, let's say, this person is a carrier, that's your assumption. You associate a number to it, you go to the next one, right? You don't think about this probability anymore. Now to you, this person is a carrier. That's your assumption for the next stage, and so on, right? So I think the answer is 1/16. Should I do one more? I don't know. Okay, now we're gonna do this one just for fun. I'm gonna do it a little bit quicker, but the thing is, if you want me to solve anything else, I mean, if what I say makes sense, just tell me, I'll solve more. So it's autosomal recessive, that's all I care. These people, they're gonna have a baby. So what is the probability this one is? Small a, small a. Okay. I assume anyone else in that branch is just, they don't have the negative gene. So what is the chance this person gonna have or this person have a bad gene? Isn't that 100%? Why do I say that? Because you gotta get one gene from your mom, one from the dad, right? So the mom one, she has only one choice, because I mean they look the same, so she's gonna just give A. He has one choice, so it's just small a, so that's the genotype of this person. Same as this one. See, the mom just big A, the dad small a, right? So just like that. Okay. Now let's look at next generation. So far, no probability. These are 100%. Next generation, this generation. What is the chance that this child would be a carrier, right? Again, the dad is AA, mom is this. Why do you assume this? Because again, it's autosomal recessive. Assume just very rare unless they give us in the question what is the chance and whatnot. Okay. Now, okay, so dad has one choice. This is 1/2 small a, so it's that, right? So, but it was 1/2, so just gonna write down 1/2. Let me just clear this a little bit. So small a is 1/2, because you have two choices out of two. You want to pick one, which is this one. So it's 1/2 that you're gonna get this one. For the dad, you're gonna have two big A, so you just have one big A choice, right? So it's 1/2. Just to make simple analogy, these are all big A, big A. So whoever is outside the family, just no problem. So same analogy works here, so it's 1/2. Same analogy works for the next generation. It's 1/2, 1/2. If it doesn't make sense, just let me know. I'll tell you why. Now, same analogy here, 1/2, 1/2. Now they get married. Each gonna contribute 1/2, or you can say 1/4. So you just have to count 1, 2, 3, 4, 5, 6, 7, 8. It's 2 to the power of 8, which I think is 256, if I'm not mistaken. So it's 1/2 times 1/2, but I have to write it 8 times. I didn't write it, but you know what I'm saying, right? It's just 1/2 to the power of 8, 1/256, right? So that would be E. I guess that's the answer.